So here's something very interesting about perceptrons, and it's that some logical operators can be represented as perceptrons. Here, for example, we have the AND operator. And how does that work? The AND operator takes two inputs and it returns an output. The inputs can be true or false, but the output is only true if both of the inputs are true. So for instance, if the inputs are true and true, then the output is true. If the inputs are true and false, then the output is false. If the inputs are false and true, then the output is false. And finally, if the inputs are false and false, then the output is false. Now, how do we turn this into a perceptron? Well, the first step is to turn this table of true-false into a table of zeros and ones, where the 1 corresponds to true and the 0 corresponds to false. And now we draw this perceptron over here, which works just as before. It has a line defined by weights and a bias, and it has a positive area which is colored blue and a negative area which is colored red. And what this perceptron is going to do is it'll plot each point, and if the point falls in the positive area, then it returns a 1. And if it falls in the negative area, then it returns a 0. So let's try it. The 1, 1 gets plotted in the positive area, so the perceptron returns a 1. The 1, 0 gets plotted in the negative area, so the perceptron returns a 0. The 0, 1 gets plotted in the negative area, so the perceptron returns a 0. And finally, the 0, 0 also gets plotted in the negative area, so the perceptron returns a 0. Other logical operators can also be turned into perceptrons. For example, here is the OR operator, which returns true if any of its two inputs is true. That gets turned into this table, which gets turned into this perceptron, which is very similar as the one before, except the line has different weights and a different bias. What are the weights and bias for the AND and the OR perceptron? You'll have the chance to play with them in the quiz below.